Hey guys, we're looking at number 3 on that checkpoint practice for power series and Euler's approximation. What we're looking at is a power series already written out, and we're trying to find a function that represents that over the interval 3, 5. So we've already talked, don't worry too much about this interval for now. I'm kind of giving you that information. All the ones that we've been working through kind of work out anyway. We're going to learn a little bit more about that after this assessment on Friday. So what you should be doing first is trying to find a common ratio so that you can then write this power series in summation notation. A little bit easier to take it from summation notation into a sum of geometric series. And so first thing to notice is you've got positive, negative, right? We've got alternating terms. So right away, you know you have -1 to the end. The next thing to look for is that number that you're multiplying, or that thing you're multiplying every term by to get from one term to the next, right? This is a geometric representation. So every one of these terms is going up by a factor of x minus 4, right? So now we've got our series written in summation notation. I'm going to write it again because if I want to see my entire r all at once, right, if I'm going to use that formula, that one that we've been using so much, a over 1 minus r, I need to have that r all alone. It can't be broken up into these two pieces. So really all we're doing is we're saying, okay, let's just write this whole thing as one expression raised to the n, right? There you go. And so what we've done is we found this piece right here. All this stuff is actually our r, right? And so now we can write our function using our sum of a geometric series formula. So what we'll have is, since a is 1, we'll have 1 over 1 minus this value of r, right? So the value of r that we have is -x plus 4, right? So that's our f of x, right? The only thing we really need to do at this point is to just kind of clean up that denominator, because it really doesn't look all that great. So you have 1 over 1 plus x minus 4. Well, of course, that's just 1 over x minus 3. So we've got this function f of x equals 1 over x minus 3. And it's a representation of this power series on the interval 3 to 5. Now, if you want to just double check that it hits that interval, you absolutely can. Remember, this radius of radius of convergence from our ratio, -x plus 4, that absolute value has to be less than 1, right? And we've worked through a billion of these at this point, where -x plus 4 would have to be greater than -1. That's our negative side. And then our positive side for the absolute value, -x plus 4, has to be less than 1. And then when you solve this algebraically, you're going to see that this works out really nicely to give us that interval of convergence that we were asked to find. -x is greater than -5. This one says -x is less than -3. And then, of course, when you divide by -1, you get x is less than 5 and x is greater than 3, right? So that yields our interval of convergence that we were supposed to have. Hope that helped. Don't forget, like and subscribe.